The way you would differentiate a function raised to a really high power, such as in this scenario, is by employing the chain rule, which says the derivative of any composite function is equal to f of prime of g of x times g of prime of x. So in this scenario, f of x would be simply equal to x to the power of 14, and g of x would be equal to x plus 2. This means that the derivative of this would be equal to f of prime of g of x, which is simply 14 times x plus 2 to the power of 13, because whenever this part kind of is exactly similar to the power rule, where you simply bring down your exponent and subtract it by 1, regardless of whatever the inside of your brackets is, and then you multiply it by the inside of your brackets, which is, in this case, 1. So the chain rule can often be thought of as an extension of the power rule, where you simply bring down your exponent, subtract it by 1. However, instead of something that you don't do in the power rule is multiplying it by the derivative of the inside of the function. However, technically, you can think of chain rule, or you can think of the power rule as the chain rule. However, the derivative of x is always 1, so you never really care for concerning it as the chain rule. So let's do some other examples. So the derivative of this would be exactly the same to the other one, would be 42 x plus 2 to the power of 41, and like the other one, the derivative of the inside is 1. So this will be equal to 42 times x plus 2 to the power of 41. So just like our power rule. So in this function, however, the derivative of the inside is not 1, so we will see the effect of the chain rule. This will be equal to 32 times x squared plus 2x plus 7. So this is kind of what our power rule says to us, and this is f of prime of g of x times by the derivative of the inside, which is 2x plus 2. So our derivative would be equal to 2x plus 2 times 32 times x squared plus 2x plus 7 to the power of 31. And eventually, as you do chain rule, you can kind of just think about, I think the most efficient way of doing it is by simply bringing down the power and then multiplying it by the derivative, and then just leaving your original function and then subtracting it by 1. So the process becomes very automatic after doing chain rule a lot. So in this scenario, we observe that we have the product of two functions, and as we covered in our previous episode, we always have to use the product rule in this scenario. So, okay, let's do the product rule and see what happens. So this will be equal to the derivative of x squared plus 7 to the power of 4 times x plus 9 to the power of 21 plus the derivative of x plus 9 to the power of 21 times x squared plus 7 to the power of 4. Now, what we observe is that we have to differentiate something using the chain rule. So we're pretty much using the chain rule within our product rule, because the product rule leads us to differentiating a function which can only be solved using the chain rule. So the derivative of x squared plus 7 to the power of 4 would be equal to 4 times 2x, which is the derivative of the inside, times x squared plus 7 to the power of 3. So as we can see, these parts to the extent are kind of what the power rule shows us, and this is our extension of the power rule. And this will be multiplied by x plus 9 to the power of 21 plus the derivative of, again using the chain rule, will be equal to 21 times the derivative of the inside, which is 1, times x plus 9 to the power of 20. And it will be simply multiplied by x squared plus 7 to the power of 4. This will then be equal to 8x times x squared plus 7 to the power of 3 times x plus 9 to the power of 21 plus 21 times x plus 9 to the power of 20 times x squared plus 7 to the power of 4. Okay, now let's try this example. So again, we see that we have to differentiate the product of 4 different functions, and similarly to the final example of our previous video, we can break this function up into two separate functions and try using the product rule to differentiate f of x times g of x, whereby we can treat this as f of x times by g of x, which can be this. So let's go ahead and solve it. So f of prime of x would be equal to the derivative of x squared plus 2x to the power of 5 times x cubed plus 1 to the power of 4 times by x to the power of 7 plus 1 to the power of 6 times x squared plus 1 to the power of 4. So this is our other function, plus the derivative of x to the power of 7 plus 1 to the power of 6 times x squared plus 1 to the power of 4 times x squared plus 2x to the power of 5 times x cubed plus 1 to the power of 4. Okay, so again, we have to use our product tool within our product tool because we have to differentiate this function over here, which is a product of two functions. So let's go ahead and solve that down here because it's going to get pretty complicated if we do it as a single step. So the derivative of x squared plus 2x to the power of 5 times x cubed plus 1 to the power of 4. We know that this is going to be equal to the derivative of x squared plus 2x to the power of 5. Now we have to use the chain rule in this scenario because it's raised to a higher power, and you can think of the chain rule kind of as an exponent rule now because you're differentiating functions raised to a very high exponent. So that's another nice way of thinking about it. So this will be equal to 5 times 2x plus 2, the derivative of the inside, times x squared plus 2x to the power of 4, which is equal to 5 2x plus 2 times x squared plus 2x to the power of 4. So 5 times 2x plus 2 to the power of 4. Okay, so that's the derivative of that multiplied by x cubed plus 1 to the power of 4. Now we have to add this to the derivative of this times this. So the derivative of x cubed plus 1 to the power of 4, we would have to use our chain rule. This will be equal to 4 times x cubed plus 1 to the power of 3. So this is kind of similar to the power rule, times by, so our extension of the power rule, the derivative of the inside, which is 3x squared. So this is equal to 12x squared times x cubed plus 1, all to the power of 3. So plus 12x squared times x cubed plus 1 to the power of 3, multiplied by our other function, of course, because that's what the power rule states. So this is the derivative of this function, and now we've just used the chain rule in the product tool, as we similar to the previous example. So this will be equal to 5 times 2x plus 2 times x squared plus 2x to the power of 4 times x cubed plus 1 to the power of 4 plus 12x squared times x cubed plus 1 to the power of 3 times x squared plus 2x. Wow, okay. So that's our derivative. This will be multiplied by this bracket over here, which is x to the power of 7 plus 1 to the power of 6 times x squared plus 1 to the power of 4. Okay, so that's half of the question done. The other half left to go. Now, we have to differentiate this function over here, which is equal to the derivative of x to the power of 7 plus 1 to the power of 6 times x squared plus 1 to the power of 4. This is equal to the derivative of x squared plus 1 to the power of 6 times x squared plus 1 to the power of 4. So the derivative of x squared of x to the power of 7 plus 1 to the power of 6 is equal to 6 times 7x to the power of 6, the derivative of the inside brackets, times x to the power of 7 plus 1 to the power of 5. So that will be equal to 6 times 7x to the power of 6 times x to the power of 7 plus 1 to the power of 5 times x squared plus 1 to the power of 4. Now we have to add this. We have to add this to the derivative of this times this. So derivative of x to the power of x squared plus 1 to the power of 4 is equal to 4 times 2x times x squared plus 1 to the power of 3, which is equal to 8x times x squared plus 1 to the power of 3. So 8x times x squared plus 1 to the power of 3 times x to the power of 7 plus 1 to the power of 6. Okay, so that's the derivative of this insane function. And we have again used the chain rule inside of our product rule. Now this would be simplifying those 6 times 7 to the power of 7 times sorry, 7x to the power of 6 times 6, which will be equal to 42 times x to the power of 6. 42 times x to the power of 6. Okay, so now we write all this down. So this equals this. So plus 42x to the power of 6 times x to the power of 7 plus 1 to the power of 5. Actually, I can just copy that down. Wow, okay. Sorry about this. Okay. Plus this times by this over here. So I'll copy this, move it down. Okay, so this is multiplied by this. Okay. Alright, this is the derivative of this function over here. So you can kind of factorize this a bit, I suppose. Actually, I don't think you can factorize this, but you can expand these brackets and you get an even more hectic function, but I'll just leave it here. So ultimately, from this video, I want you to understand that the chain rule is simply an extension of the power rule. And it kind of shows that in mathematics, through these examples, mathematics is all about decomposing a problem into a more simpler problem, such that you can solve it using fundamental techniques or logic. And yeah, this is the chain rule.